Okay guys, so we're going to continue talking about quadratics today. Remember, it's our parabola shape, okay? This parabola we're going to talk about later, but for right now, let's just talk about the equations, okay? We've seen a lot of parabolas and all the different key parts of it and stuff, but we really haven't worked much with the equations of quadratic functions, okay? So before we really get started, make sure you have paper and pencil so you guys can take some notes, okay? Alright, so we are talking about quadratic functions. Today we're going to be looking at the different types of equations that can be written and how those are related to our parabolas and all the key features that we talked about. Okay, so a quadratic function, let's first take a look at the parent function. Okay, parent function is simply y equals x squared. This is the one that you guys analyzed in the warm-up either yesterday or Wednesday. Okay, this x squared is what makes it a quadratic. Okay, if x to the power of 2 is the largest exponent there, then you have a quadratic function. Okay, now for these quadratic functions we have three ways we can represent them. We have standard form. I could spell standard form, and that is ax squared plus bx plus c. Okay, a, b, and c are just numbers. Okay, so what we have here is our standard form, and a, b, and c we're going to use to sort of analyze what our quadratic is going to look like. Okay, the next one that we have may look familiar to you because it's very reminiscent of what we did with absolute values. It's the vertex form. Okay, we have x minus h squared plus k. Oh, I almost forgot the a out front. Let's do this. A. Okay, so that looks a lot like a absolute value of x minus h plus k. A lot like that one that we did before, okay? And what you can kind of guess is this h and this k in vertex form is going to help us with our vertex, okay? And then finally, we have what we call factored form. Okay, and that one looks like this. X minus x1, x minus x2. Okay, now what you'll notice about this one is there is no squared. However, when we multiply these x's that don't have the numbers with them, that's where we get our x squared. And these x1 and x2 are just our different numbers. We're going to see these in our graph in a little bit. Okay, so with all three of these, we can actually tell different things with our quadratic functions. Alright, so here's the first one we're going to look at, and that's standard form. What we're going to see here is ax squared plus bx plus c. Okay, this is probably the most familiar way you're going to see it. Now, what we can tell right off the bat from this equation is our y-intercept. Okay, just by looking at this equation, we'll be able to tell where our parabola hits that y-axis. Okay, the y-intercept is always found at where x equals 0. Okay, and what you'll notice about this is if x equals 0, a times x squared, this becomes 0. B times x, this becomes 0. Everything becomes 0 except for c. Okay, so since the y-intercept occurs where x equals 0, c is the y-intercept. Okay, So you can tell where the y-intercept is from C. You can tell also the direction of the parabola using this as well. Okay? So that's if it's going up like a smiley face, up, or down like a frowny face. All right? And we can tell that using A. All right? If A is greater than 0, or if it's positive, it's a smiley face. It's facing up. If A is less than 0, or if it's negative, so just put negative in there, then it's that frowny face. It's facing down. Okay? We can actually tell a few more things with this equation as well, including the axis of symmetry and where the vertex is, but simply by looking at the equation, we can tell these two things. Okay? Let's take a look at what we can see with the vertex form. All right, so here's our vertex form. We have f of x equals a times the quantity x minus h squared plus k. Okay? We still have that a there, so from vertex form we can still tell if it's going up or down. Okay? If a is positive, it's up. If a is negative, then it's facing down. But h and k are just like in absolute value. With vertex form, as you can guess, you can find your vertex. Okay? And it is at hk. Make sure this negative here tells you that you need to take the opposite sign again of the h and keep the sign for the k the same. Okay, it's the same thing we did before. You want to find the x that makes this equal to 0. Okay, and you want to use the k as the same. All right, and that's vertex form. Remember, switch the h, keep the k the same. All right, this is our final one before we get back to our parabola from the beginning. Okay, here we have our factored form. Okay, f of x equals the quantity x minus x1 times the quantity x minus x2. Okay, x1 and x2 are actually going to be able to tell you what your x-intercepts are. Okay, where it hits the x-axis. Just like your y-intercept, it's where it hits the x-axis. Only in this case, instead of having just one, like we have with the y-intercept, we're going to have two in most cases. Okay, so in this case, we have x1 and x2 being our y-intercept, or x-intercepts. And what you'll notice too is that minus sign, just like in vertex form, tells us that we need to take the opposite signs again. Okay, so make sure that if you're looking at a factored form and you want to know what the x-intercepts are, you're taking the opposite of whatever these numbers are. All right, so let's take a look at our example from the beginning. Okay, and let's just label the few points that we see here. Okay, so first off, we have our vertex. Okay, we have our y-intercept here. I also have my two x-intercepts here. Okay, so I can actually predict these if I look at all the different equations for this. So here is the standard form of this equation. Okay, So what you'll notice is x squared plus 4x minus 5. The minus 5 right off the bat told me where my y-intercept is. Notice it's 1, 2, 3, 4, 5 down. Okay? Also, the a, remember if there's no number in front, it's a 1. This is a positive 1, so you see it's a smiley face shape. It's facing upwards. Okay? Now, we can do a little math magic and turn this into our factored form. Okay? Let's see here. You will not have to do this, but let me show you how these different things come about. So if I actually add 4 and subtract 4, so I'm basically adding 0, okay, what I'll do is this here can be simplified into x plus 2 squared, and this over here becomes minus 9. There, I have my factored form. Okay, this method is called completing the square. Right? I turn that into a perfectly square that I could factor. We'll talk about factoring later. But what you'll see here is this tells me that if I take my h minus h, I need to take the opposite. So my x should be at negative 2, which it is. And this one stays the same, negative 9, which it is. Okay, so this vertex is at negative 2, negative 9. Now, finally, let's do the factored form. And for factored form, I'm actually going to go back up to this one. Okay. So the way I do factored form is I use this little x method that you guys are going to see later. I have to figure out what two numbers multiply to this and add to this. That is 5 and negative 1, which means that my factored form should be plus 5 x minus 1. Okay? And from this, you can see the opposite. This tells me that one x-intercept is a negative 5, and this one tells me that one is a positive 1, which you can see here. 1, 2, 3, 4, 5, negative 5, and a positive 1. Okay? So, finally, just to recap, the standard form can tell you your y-intercept and whether it's facing up or down. Your factored or your vertex form can tell you where your vertex is located. Okay? And finally, your factored form can tell you where your x-intercepts are located. Okay, guys? All right, that is it. Just answer that one question for me, and then you guys will be good. All right, have a good weekend.